Hello everyone, it's Mohsen again and welcome back to our YouTube channel. So today we'll be looking at broken authentication loose comparison. In the previous session, we learned about broken authentication and coded bypass, where we were able to log into a page, a system, by using the hard-coded credentials. So today is going to be a little bit different but the same. We're going to exploit broken authentication loose comparison. So this is what we're going to do. We're going to learn about JavaScript type coercion and broken authentication loose comparison, exploiting loose comparison vulnerabilities. So by the end of this session, we will learn what JavaScript type coercion is and how it works. We will learn to exploit broken authentication flows, and we'll also learn how to prevent common flaws in authentication. So to better understand this video today, we need to do the practical before we go to explanation, and that's exactly what we're going to do. So without further ado, let's just dive into the video. So right in front of me I have my lab. So this is the lab. You need to get the access code, lab access code, to log in and be able to practice anytime you want. So you just have to contact AstralGuard Cyber Academy. I'm going to leave all the links in the description so you can be able maybe to get yourself access code to practice anytime you want. So let's just dive into the video. I don't want to waste much of your time. Alright, so right in front of us we have a login page where we have two panels, like one is the authenticate panel and the other is the request or response panel. So before we start, you need to know something about this. So we're going to look at broken authentication loose comparison. So here they are giving us some clues that authentication check uses the equal instead of the triple equal sign. So we're going to exploit JavaScript type coercion to login. So here they're telling us that try setting the password to different types, not just string, to trigger the loose comparison. Seeds ID or whatever. There's a lot of stuff here. They're giving you a lot of clues so you can try out. So we even have the request response where we show exactly what was sent to the backend and what the backend brings for us. So let's get started. And another thing you need to know is you can't exploit this lab when you do not know the right username or operator ID. So no matter what you do, you need to be knowing the operator ID. So there is a lot of ways how we can get the operator ID. One of them is by brute force. So but we're not gonna do that today because it's gonna make the video very long and boring. So today we already know the operator ID, so we're just gonna try to log in by exploiting the loose comparison vulnerability. So today the operator ID or the username is simple. Just it is, or I don't know if it's right. Yeah, that's the username, and the password is just 0. So before we initiate auth flow, we need to know a few things. We need to understand our interface. So what do we see right over here? We have the operator ID, which is the same as the username, and this is the username, and we have the password, which is a raw input, and then here we have the same password as. So this is very important. So right now it's a string. By default it's a string, but you can change the password and send it as a as a number. You can send it as a boolean true, you can send it as a boolean false, you can send it as a null, string, and array. So first we're going to send the password as a default, as a string. So I want you to be very careful about this. You need to pay attention so you can learn something very brand new today. So the operator ID is right here. This is the password, and we're sending the password as a string. So here in the request panel, in this here, right over here, we shall be able to see the payload that we sent to the backend, and here we shall be able to get the response that we get from the backend. That's pretty cool. So this is the request payload. You can see the payload we send, the username is course 0, and the password we sent is 0. It's a string, and the type of password is a string. We can see it from here and here. So this confirms that we sent the password as a string. So that's very good. So when we come right over here, we see that the authentication has been successful, access granted, and welcome user. So the flag is broken out, lose comparison. Then when we come right here to the response from the backend, we see that success is true. That means we've been able to log in successfully, and the username is course 0. That means this is the username that we used to log in. And the coerced shows it's true. That means there was type coercion. I'm going to explain this later. And the supply type of password was a string, which is okay, because here we say let's send it like a string. That's fair, right? And the store type of password in the database is a string, and the supply type of password, value, is a 0, which is a string, and the stored value is a 0, also a string. So that makes the whole thing straightforward. So there is no any kind of magic here. It's the expected behavior. So there is no magic here. So you need to take note of all these scenarios. In the first scenario, we've sent whatever the backend expects. So what is the logic here? We shall leave everything intact. We shall just change the type of password. In the first scenario, we sent the password as a string. So right now, what if we send the password as a number? What's gonna happen? Guess what's gonna happen? Okay, no worries. Let's see that. Do you see this, guys? So we see that we've sent the password as a number, and we've been able to gain access. So you can see access granted, welcome, and frag broken. And the payload we sent is the username, which is course 0, and the password is 0. The type of password is a number. Then again, where the magic comes in is right here. Success true, it means the login has been successful. And the username we used is course 0, which is okay. And the here coerced is true, it means there was JavaScript type coercion. I'll explain that later. And the supply type of password is a number, but the stored type of password is a string. So how is that possible? So that's what we say this is loose comparison vulnerability. The stored type of password is a string, but we sent a number, but we've been able to log into the system. So that's where the vulnerability comes in. So the supplied value is 0, which is a number, and the stored value is 0, which is a string. So take note of all these scenarios. I'll explain them later, right after this. Then let's try something else. In another scenario, what if we send the password as a boolean true? Let's see that. Can you guess what's going to happen? Shall we be able to log in or not? Alright, let's see this. So we see access denied, invalid credentials, and this is the payload we sent. We send the username as 0, and the password is true. We send the password as a boolean true, and the type of password is a boolean. And then the response from the backend is success false, meaning login was not a success, was a failure, like you weren't able to log in. And the error is invalid credentials, the credentials were not right, they're not correct. So, and we also see the debug says supply type of password is a boolean and the stored type is a string. You need to take note of all these scenarios. We sent a bool, which is false. We sent a boolean, which is true, and yet the stored type of password is a string, and we were unable to log into the system. All right, that's okay. Let's then try to change the password. The password into a boolean. So this is another scenario. We're going to use the very same operator ID or username and the very same password, but this time around we're going to send the password as a boolean false. So guess what's going to happen here? Shall we be able to log into the system or not? Well, let's try it out and see. Access granted. So this is all some kind of magic. In the previous scenario, it was almost the same. We sent the very same operator ID and the password, but this time around it was in form of a boolean for true, but we were unable to log in. But this time around we only changed the boolean to false, but we were able to log in. I'll explain all these. So let's come and analyze our request, the payload that we sent in the backend. So the payload, the username is coercion0 and the password is false, and the type of password is a boolean. And then the response from the backend, it shows that success true means we've been able to log in successfully, and the username is coercion0. That is fine because that's what we have right here. And coerce true, that means there was coercion. And the debug shows that supply type of password is boolean and the stored type is a string. Then how is that possible? The password in the backend in the database is a string, but when we send the password in form of a boolean, which is false, we gain access. And here the backend shows us the supplied value was a false and the stored value was a 0, but we gain access to the system. So this explains our broken authentication loose comparison. Alright, let's go to another scenario and see. What if we maintain everything, we leave everything intact, but only send the password as a null? What's gonna happen? What do you think is gonna happen right here? Okay, let's give it a try and see. Access denied, invalid credentials. Let's analyze the request. So the payload is username is coercion0. This is what we sent to the backend, and the password was a null, and the type of password was object. And the response from the backend says success false, we've not been able to log in. Why? The error is because invalid credentials. And the debug shows that supply type of password was an object and the stored type of password was a string. So access denied. Who can ever explain this? So this is pretty easy, and right now I'm gonna explain why it's been behaving like this. So this shows our broken authentication loose comparison vulnerability, and I'm gonna explain it right here. So we're going to learn about JavaScript type coercion. So what is JavaScript type coercion? So in this lab today, we analyze deliberate authentication vulnerability caused by loose equality comparison. So this is, when I say the loose equality comparison, this is what I mean. Let me show you. So this is the loose equality comparison in JavaScript, and this is the strict equality comparison. So in our lab today, we analyze the deliberate authentication vulnerability caused by the loose equality comparison. This vulnerability allows the attacker to exploit the type coercion to bypass password verification and gain unauthorized access to the system. Right now we're going to see something. Let me first do this. When I come right back here, in our backend we have a code of this kind, exactly like this one. So we see it says like, if the password is equal to user the password, then grant access. So where's the problem here? It's right here. Here the developer or the programmer, wherever they are, they use the lose equality operator. So this is very risky. It's very bad. This is what causes the vulnerability that we saw, all the scenarios that we saw.
I'm gonna break them down so you can understand how the vulnerability comes about. I know everybody's wondering, you're like, how does this make the lab vulnerable? But this is what we're gonna look at right now. Alright.
So we saw that the stored password was S0 and a string. But when we send the password as a number, we gain access. This is due to JavaScript type coercion. What is coercion? Coercion is simply changing from one type to another. It is very automatic when you use the lose equality comparison. The JavaScript is going to do what we call like comparison, like the coercion, changing from one type to another before it does what we call the comparison of the password. It has to make sure they are all of the same type before it does comparison. That's what we saw when we send the password as a string. When the password is a string in the backend in the database, but we send the password, the very same password, but as a number, the JavaScript is gonna convert it or coerce it to make sure that they are the same types before it does the comparison. So that is the simple logic that has been happening in our lab. Let's analyze all our three scenarios in explaining what has been happening. In the first scenario, it was very obvious and it's actually the expected behavior. We sent what the backend expects. We sent the right operator ID or username. We sent the right password in string form as the backend expects, and we were able to log in. That is very fine and okay. Then in the second scenario, we send the same operator ID or username. We send the same password, but this time around was a number or an integer. So we see that we've been able to log in. Why? Because of what I just told you, JavaScript type coercion. JavaScript is going to do what we call type coercion to convert, to make sure that all the types are the same before it does comparison. This is because of the use of the lose equality operator that does what we call that brings about the type coercion. In the third scenario, sent a boolean true, but we've not been able to log in just because a boolean true means 1, and when it is coerced and compared, so the passwords do not match. Here the password was 0, a string, and when coercion happens and the boolean is being changed into a 1, so and then compared, this brings a 1 and this brings a 0, so that's not possible. That's why we never log in successfully. Then in the other scenario, the fourth scenario, we sent still a boolean, but this time around it was a false. So the false turns it to a 0 and then compared, so we can access. I hope you understand that. We sent a false, and when a false is being coerced, it is made like it returns the value as a 0, and then when it returns the value as a 0, then there's gonna be comparison. And when they compare the 0, remember we already have the 0 in the backend, so this brings out about the vulnerability. I need to show you something very small. Actually, I want to show you how you can, I want to show you the difference between the strict versus the loose comparison. So this is the strict comparison, and this is what you're recommended to use. This is the strict comparison. So this checks for the value and type. It compares the value and type if they're both the same, and there is no automatic coercion here. Then this loose one, it checks for the value only, it doesn't mind about the type. So this performs what we call type coercion. If the types differ, it tries to do type coercion, converting from one type to another, and then does the comparison. So this brings about the vulnerability. So let's see how we can avoid broken authentications due to weak comparison. It's very simple. Programmers, developers, you need to use the strict comparison. Yeah, you need to use this. Also, we need to validate input. We need to hash passwords and compare hashes. We need to avoid faulty shortcuts and to test edge cases. So that's how we can go about that. So thank you for watching this video today. Remember to sign up for AstralGuard and then get your lab access code. You'll be able to practice anytime you want.